Hello everyone, welcome to my programming club. Today we will be solving another daily Leetcode challenge, and the challenge name is path with minimum effort. So the challenge statement goes like this: you are a hiker preparing for upcoming hike. You are given heights in a 2D array of size rows and rows into columns, where each entry in the heights table represents the height of the cell row comma column. You are situated at the top of top cell 0 comma 0, or the leftmost cell, top left cell, and you hope to travel to the bottom right cell, which is row -1, column -1, since the array will be 0 indexed. So you can move up, down, or left and right in 4 directions, and you wish to find a route that requires minimum effort. And effort is defined as a route's effort is defined as maximum absolute difference in heights between two consecutive cells of the route. So let's take this example for let's say you have to start from this cell 0 comma 0 and end at this cell row -1 column -1 cell. So let's say you take this route. Here, what is the maximum absolute difference between two consecutive cells? Two consecutive cells will be two neighboring cells. So it is 5 minus 3, 2, or you can say 3 minus 5. It will be the absolute difference, so it will not matter. So in this case, it will be 2. So if we take the route, this green one, then the maximum absolute difference will be 2, and this route will give you minimum effort. So you have to find the minimum effort possible in a route starting from top left cell to the bottom right cell. So let's have a look at the constraints. The rows and columns are of order 100. Length of number of rows and columns, and the value of heights is of order 10 raised to power 6. So how you will be solving this problem? What we will do is we will use binary search. You may ask what will be the quantity or the entity if you will be using binary search. So we will be binary searching for minimum effort. Since it's mentioned in the constraint that maximum height can be 10 raised to power 6, and so the difference of heights can be 0 if the heights are same of two adjacent cells. Let's say this is a grid and these two are adjacent cells. Now if both of them are having same height, in that case their difference will be 0, and if let's say one is having a height of 1 and another is having a height of 10 raised to power 6, so the difference will be of order 10 raised to power 6. So the binary, we will binary search from 0 to 10 raised to power 6 plus 1. This will be our left and right range of binary search. So our answer will be lying between this two integers, or say answer, or say minimum effort. And we will binary search for it. Now you may ask how you will be deciding which half to reduce in binary search. How to decide which half to reduce in binary search. Those of you who are new to binary search, I will be providing a link for an article describing binary search. There you will be able to explore what binary search is, and then you can come back to the solution, and then you will be able to understand the solution in a better way. So what we will do is, so the overall time complexity of this binary search will be order of log of 10 raised to power 6 into time taken for checking if a if the effort we are if the effort we are suggesting as our answer is a valid one or not. So for this we will use depth first search, DFS. We will you may ask what we will depth first search for. We will check if a route exists with effort proposed by binary search. And accordingly we will reduce our search space and then we will find our answer. And then by reducing search space in binary search, we will find our answer. So this DFS will be taking O of n time, or say O of n time, n here is 10 raised to power 6. So the overall time complexity will be log of n into n. So this will be of log of 10 raised to power 6 into 10 raised to power 6, which will be lesser than this 10 raised to power 8 limit of number of operations, 10 raised to power 8 number of operations. Allowed in 1 second. So basically what happens is, if the number of operations of your program or the number of operations of your that your solution will be requiring exceeds or becomes equal to this 10 raised to power 8 operation limit, then you may get a TLE, otherwise your solution will be getting accepted. You will get a AC. So you can check also. Ten raised to power 6, it is 19 only, as you can see. So 19 into 10 raised to power 6 is lesser than this 10 raised to power 8 limit. So those of you who are not familiar with this limit concept, I will be providing a link of an article describing how the time complexity of accepted solution varies with size. So, you can explore this article, and it will be the same thing that 10 raised to power 8 operations are allowed in 1 second. And if your program is performing lesser number of operations than that limit, then your solution will be getting accepted. So without further delay, let's have a look at the implementation, that you will be able to understand the approach in a more clear way. What you will do is, this is a modified binary search over the answer, which is minimum effort. So what binary search will do is that it will propose a possible effort, and then we will check if a route with this possible effort, this effort per se is possible. If yes, then we will reduce the upper limit of our search space, is nothing but right. And if that's not the case, then you have to reduce the search space by increasing lower limit of the search space, which is left. So we will check if this effort that is being suggested by binary search is valid. If yes, if route is existing with this effort, or say less, then it will be your current minimum. It will be your current minimum effort. Otherwise, you will search for effort in a reduced search space by increasing your lower limit of the search space, and at last you will return your search space. Is valid effort is a function that will call a DFS function. It will call for a DFS function to search for a route with effort less than or equal to proposed effort by binary search. So since you are allowed to move in 4 directions, this will be the 4 direction in which you can move. These will be the 4 directions in which you can move. So this is pretty much a standard DFS. Those of you who are not familiar with the DFS also, I will be providing a link of an article describing what DFS is. depth first search. Basically, it's a searching technique in which you search till the very end of a branch and then explore other options. So I will be providing a link for this also. So in total, 3 links will be provided: binary search and this time complexity relation with the limit of 10 raised to power 8 operations, and this depth first search. So this is a standard depth first search. Whenever you will find a root with effort less than or equal to the proposed effort, by binary search, then will return true. And this is to check whether the coordinates lie inside the, this is to check whether the coordinates lie inside the grid, or say which or this heights array or grid, and if and the cell is visited or not. So that's pretty much it for the approach and solution. So it will be available in C++ and Java both. Thank you for watching. If you are having any doubts in this approach or solution, please feel free to ask your doubts in the comment section. Thanks for watching again. Thank you.